Welcome back to Parasitic Draw, Part 2. In our first video, we took a look at how to diagnose parasitic draw. The steps that we took first was that we charged the battery. We locked the doors, remember my wood clamp trip, and then we closed the hood latch. From there, we waited for 10 minutes to 2 hours. We did this to make sure that all systems went to sleep. And don't forget, our specification is about 50 milliamps or less. If we have anything greater than 50 milliamps, we are dealing with a parasitic draw. And then, if you remember, we went ahead and diagnosed this by pulling fuses, watching our parasitic draw to drop below 50 milliamps. Well, we're going to take a look at another way to diagnose this.
Here's the problem. When pulling fuses, this can wake systems up. The result? You have to wait another 10 minutes to 2 hours. Notice our parasitic draw is in a good range right now. Watch when we get down and pull the fuse out. Notice that our parasitic draw has jumped to 442 milliamps, far beyond the specification. Now that we put the fuse back, we wait. What we need is a good, non-intrusive way to identify if current is flowing through a fuse without removing the fuse. Well, guess what, guys? The good news is there is. We can do it with voltage drop. Let's review what voltage drop is. Here we have just a very simple circuit. We have a battery, a fuse, a circuit, a bulb, a switch, and ground. When we close the switch, that allows for current to flow from power to ground. Notice our multimeter before the bulb shows 12.5 volts. After the bulb, it shows little to no voltage, or 0.05 volts. So, when I have 12.5 volts minus that 0.05 volts, our voltage drop through that bulb is 12.45 volts. Now let's take a look at this circuit with the switch open. Notice our multimeter before the bulb is reading 12.6 volts. Notice after the bulb, it's reading 12.6 volts as well. Why is that? Well, when current doesn't have a complete path to ground, a voltage drop does not become a voltage drop. So, in other words, if I had 12.6 before the bulb and 12.6 after the bulb, our voltage drop is 0. So in other words, guys, when current passes through a component, voltage is used up. The multimeter can actually do this calculation for us. I like to look at it this way, is that when I'm doing a voltage drop test with a multimeter, I am looking to see the voltage that's used from the red lead to the black lead. Okay? In this situation, we are seeing that the bulb is using 12.4 volts. Now, if the battery has 12.6 and we're using 12.4, where's that extra 0.2 volts? Well, that is used up in the circuit, the fuse, and in the switch. So in other words, guys, that would mean that there is voltage drop that happens over a fuse, over the circuit, and over the switch. Now, in order for us to have a voltage drop, we need resistance. And I'd like to bring your attention back to Ohm's law. When it comes to resistance, resistance is actually increased or decreased based on the diameter of a conductor. So in other words, guys, what is a fuse? We know it's circuit protection, but notice that the conductor is actually considerably smaller than the wiring that's in the circuit. So what that means is that it will have a larger voltage drop over a fuse than it will over wires. So, what we can do is check for voltage drop over a fuse to identify if current is flowing. To do voltage drop over a fuse, we're going to first take our multimeter and put it in the voltage port and the COM port. Then we're going to take our dial and move it to millivolts. This is going to be a very small voltage that's dropped over the fuse, so we want to make sure that we're in millivolts rather than voltage. Notice in the millivolt setting that our numbers are not stabilized. When we have good contact on the fuse, these numbers will stabilize. To check voltage drop over the fuse, we're going to take the two leads of our multimeter and put them on the tangs of the fuse itself. We already know that we have a parasitic draw on this vehicle, so now that we've moved into the inside of the vehicle, we're checking voltage drop over fuses. We can see we have no voltage drop over this fuse. Over this fuse, we can see that we have 0.7 millivolts drop over this. That means current's going through this fuse. To calculate the amperage moving through that circuit, we can utilize this chart. Now, charts similar to this can be found online. But across the top, we identify the different fuses, both by amperage and color. Down the left-hand column, we have the millivoltage drop. Now, our millivoltage drop was 0.7 millivolts. And then if we follow that over to the brown 7.5 amp fuse that we found our drop on, we find that we were dealing with a 65 milliamp amperage draw. This alone goes ahead and blows our specification right out of the water. So the draw from our fuse was 65 milliamps, or in other words, 0.065 amps. That's it. Now, imparting a couple of words of caution. First of all, remember a voltage drop over fuses that normally have current flowing through them with the vehicle off is normal. In other words, radio fuses, clock fuses, etc. Also, don't measure voltage drop over the short pin. There is no chart for that. Besides, the short pins normally carry current for circuits that are supposed to always have current flowing. Thanks for watching, everyone. Hopefully this is helpful for you for diagnosing those pesky parasitic draw problems.